Well, hello everyone. Thank you very much for having me. My name is Borna Hajimiragha. Don't try to spell that last name, but Leslie did a pretty good job. I am the CEO of MSD Rebar Inc. and from Toronto. Before I start my presentation, I really wanted to thank ACI for solving two problems in concrete. There is one enemy out there, and I consider them as lumber and wood industry, and that's a big threat to our industry sitting in this room. Hopefully they don't have any spies sitting here. But that's the real enemy out there, and there are two pinching points on concrete. Is concrete really durable material? Is it really what buildings supposed to be built? Or number two, is it really a green material? So I'm very glad to see ACI is solving those two problems. Number one, addressing all the CO2, so I'm very glad to see that. And number two, products such as fiberglass rebar is going to eliminate the existing of corrosion in the structure. So we're almost tackling this too. This presentation, quickly, I'm going to go over the cost of the corrosion. I have to go really fast because there's a lot of slides and some good videos. Example of the corrosion, why GFRP is becoming a material of a choice, some of the recent changes in code, some of the benefits, some of the field examples, and why is it a greener product. This project is a Port Clinton in Ohio. The entire port, 1.2 miles, designed with epoxy-coated rebar. Everything switched to fiberglass rebar, and its installation cost. Everything was better than traditional epoxy-coated bars. This is not new. A cost of corrosion in Canada and was estimated to be about $52 billion US in Canada. In US, that's probably about $1 trillion. Who's paying for this? Taxpayers. All of us are paying for all these repairs. And these are the examples of the corrosion. You guys have seen this every day. I don't need to repeat that, but you know about parking garages, sidewalks, bridge decks, barrier walls, and so on. Also, a lot of people ask this question from me, is that, Borna, why do you keep talking about the rebar? Concrete itself goes bad. Well, that's not true. If you look at the Roman Empire, 6th century, they actually built the first bridge using salt water and cement-based materials. That bridge is still there with zero sign of corrosion. In 2000, you build the bridge, and that's the corrosion. The problem is, by putting the steel in the rebar, you're introducing the cancer inside the concrete. It's just a matter of time that cancer grow up and basically destroy your concrete. Also, I'm not the first one sitting in front of you guys and talking about the corrosion. This has been a challenge for structural engineers and engineers out there of how do we solve this problem. Black steel rebar, early 1900s, everybody excited. This is a great material. 50 years after, oh my God, everything is rusting. What are we going to do? Well, let's put some epoxy painting on top of that. Well, let's put some galvanized on top of that. Well, we all know both of them didn't work because as soon as the layer of epoxy or galvanized is gone, the corrosion happened. So fiberglass rebar is also not a new material. It's been out there for 30 years, and there is a lot of research and development, a lot of universities, a lot of end users putting it in testing. So we're very close to say fiberglass is really becoming material of choice because there is a nice time gap of materials being out there, and everybody's been using it in different industry. Also, fighting against corrosion is not the rebar, but structural engineers always thinking about how am I going to fix that corrosion? Well, put some waterproofing membranes. Well, put some CNI, DCI, corrosion inhibitors, epoxy patches. You know, it's out there, and each of those items cost money. Why do you do all this? Because you want to prevent the steel rebar from rusting. Well, why don't you remove it from the first place and replace it with a material that doesn't rust at all? Sorry. So what is the solution? The solution is glass fiber reinforced polymer rebar. And that because you're eliminating the entire corrosion once for all. For those that doesn't know what fiberglass rebar is made of, it's really you grab a piece of rebar and you keep polishing it to a diamond polish. This is what you will see on the left side. You will have glass fibers that are, so if you can see right here, this is about 20 microns. that's about one of your hair diameters. So each of those fibers are about a third of your hair diameters, and they are all enclosed with the high performance vinyl ester, epoxy, very high performance polymer to put this. 85% of that material is glass. It's silica based, and the remaining 15% is just a binder to put this together. Fiberglass rebar is not new, as I mentioned, and a lot of you guys might ask this question saying, Borna, the way you're explaining this is the best material ever out there, why we haven't seen it often? Where have you guys been? Well, we have been out there. It's a slow movement. So number one, for structural engineers to adopt a new materials, they need to see a lot of history. Picture on the right side, you see the first bridge made with fiberglass rebar in early 1990, actually 1985, I believe. In Minnesota, that bridge is, that's in Virginia, that bridge is still intact with zero sign of corrosion. What's really funny enough is that bar used there doesn't even comply with today's ASTM codes. So you can see how much the industry is advancing, but that bridge is still there. So number one is a lot of structural engineers want to see that time history. Hey, yeah, there is a structure sitting there for 35 years. Number two, in general, construction is a very slow adopting machine. I mean, you look at your cell phone, your computers, your cars, every year you have something new and constructions. I think the last invention was when they found steel rebar, so probably 100 years ago. The number three is really the most important one, is the engineering and codes, which I'm going to talk about it a little bit in the next slide. The next one, increase in production. Really, the price of fiberglass rebar was always more expensive, so cost was an issue. Today, that's been eliminated. Really, the cost of fiberglass rebar is almost as close as black steel rebar. You're lighter weight, corrosion-free. That's why it's gaining a lot of momentum. And the service life. So a lot of owners, DOTs, they are expecting that service life. You're all paying for these structures. Everybody want to see that 100 years of service life out there. And the last one is the support from DOTs. It's really Department of Transportation out there are looking for better and more sustainable solution that can make these bridges more sustainable and more resilient. A little bit about the code. IBC and IRC are the main two governing codes, and so far fiberglass rebar was not being part of these codes. We're really hoping in 2023 or 2024 fiberglass rebar will become part of international IRC and IBC, which is a huge step forward for our industry. But what we have been doing so far, you guys might have said, okay, well, Borna, how come you have been selling your product? Well, thanks to ICC. ICC was the only standard that was acceptance criteria that was performance written based on the performance of the materials, and it allowed our products to be able to go out to residential markets. So ICC was a huge step, which started in 2014. That was the first version came out and revised in 2022, and it's keep evolving, and that's really helped our materials to be out there, and we try to sell the materials by using ICC basically. So as I mentioned, this major standards is coming to. Sorry, this one is the IRC and IBC is going to recognize fiberglass rebar in 2024. So that's really a huge step forward for us. That's you can see the proposal change that's submitted. And also the new version of ASTM is coming to life. So the new ASTM D7957, which I'm also a voting member, that's also being revised, and they allow the better performance. So now as I mentioned, if that bridge 35 years ago used that rebar, the first generation of fiberglass rebar, the gap is probably from level 1 to 95 now. That's how much change it is. That's the ASTM D7957 new version. And also the next slide is really showing you that our industry has been really working hard to make the life of structural engineers out there easier. We do have now softwares, commercial softwares such as, Altair. I don't know if you're familiar with S-Concrete, S-Frame, S-Line. Now there are actually softwares that are equipped with ACI 440, and you can go ahead and use it and design your structure. So now everybody has a design tool in their hand that they can use. Oops, sorry, I just pressed the end button. There you go. Yeah, so also materials becoming very, very popular in a lot of regions. Just to give you an example, Houghton and Brampton are not always about the corrosion. They're actually fighting against the loss of networks. I want to ask this question. How many guys have walked into elevator and with your phone on and you lost signal? I can tell you all of you has experienced that. One of the major reasons is elevator shafts are reinforced with so much steel rebar that as soon as you walk in there, all that steel is stealing your signals. If today you live in a condo, you have a 5G on your network, I can guarantee you your 5G won't work in a condo. And one of the reasons is the amount of steel you have. So Houghton region is planning to build the smart community. They want everything wireless, everything surgery to be done, from overseas. And unfortunately, steel bring you some limitation because the faster the network, the lower the frequency and harder to penetrate. Or Brampton region, some of the firefighters have difficulty to communicate with each other in case of fires. As you might know, Florida DOT, Ohio DOT, Michigan, Maine, Ministry of Transportation of Ontario, Quebec, Texas DOT, they're all having a specification for fiberglass rebar. So it's nothing new out there, but it's just gaining a lot of traction now. It's a sad story, but the true story that Surfside condominium, the collapse of condo in Miami was directly due to the corrosion of the reinforcement. And I don't know if you're following the news, but Florida is making it very, very difficult for the new condominiums to be built, and they have to be with what they call premium reinforcement. It's either fiberglass rebar or stainless steel rebar, which you know what is the cost difference. I don't need to tell you that. So why consider GFRP? A lot of ministries of transportations in Canada and United States are adopting this technology. Now the material is ICC, ASTM, CSA, AASHTO, ACI. There are lots of codes out there that engineers can refer to. It's reduced the construction accidents and back injuries because of the lighter weight. Much easier to install. So in summertime or winter time, you can really go out there and touch the bar without burning your hand or without freezing your hand because the material doesn't conduct cold or heat. So that's a huge benefit when it comes to the performance and labor side. And really, it's a removed unnecessary cost of the corrosion. So you don't need to put the corrosion inhibitors, waterproofing membranes. You might need waterproofing membranes to make sure the water doesn't penetrate, but at least you're not worried about the corrosion of your reinforcement. And obviously, it reduced the long-term maintenance cost, and it keeps the environment much cleaner. This one slide is really showing you all the benefits of fiberglass rebar. We talk about the corrosion. We talk about being lighter weight 4 times. I'm going to show you some videos on that. The bond strength. Not all fiberglass rebars are made equally. There has been a lot of new generations of the product. Today, products such as MSD bar have about 3 times higher bond strength to concrete. And that was one of the unknown questions out there, that how does the material adhere to concrete and so on. Next one is really easy to fabricate the materials. Fabrication process is significantly required less energy. You can have 500 bars and cut them with a diamond blade in 2 minutes. So the fabrication cost and the energy required to fabricate is significantly less. Material is fire rated. Funny enough, a lot of people believe, oh, it's FRP, it's fiber reinforced and it's a polymer base. How does it work? Yeah, we have a lot of test data. Hopefully the next ACI, we will actually going to present the fire rating, but we have achieved over 3 hours fire rating in buildings. The tensile strength is over 3 times, guaranteed tensile strength of 145 KSI, which compared to 40 or 60 KSI steel. The material has significantly higher fatigue strength. This is one of those misconceptions out there. On the next slide, I'm going to show you a video that, hey, fiberglass is brittle, it's going to break, it's going to fail, it doesn't give you a warning. And next slide, I'm going to show you some cool videos. Next one, which is very important as part of the sustainability program, is the economical curing. Concrete is responsible for use of 10% of the clean water in the world. And clean water is very difficult in a lot of regions to find. And the main reason you can't use that is because of the steel corrosion. So as long as you're using something that doesn't rust and your concrete aggregates are non-alkaline resistant, aggregate, then you should have no problem. Dr. Tony Nani at University of Miami has done a lot of research with Florida DOT, and all those publications are out there. Very interesting to read. Material is not conductive, so we already talked about that. You don't need to ground the materials, and the thermal non-conductivity. I also talk about that with you guys. And the material is significantly greener. If you walk to our facility, we are producing over 60,000 metric ton. It's equivalent to really a big mill of steel, and we are using existing electricity foundation in our building that was there for 30 years ago. So we didn't need to bring a nuclear power plant there. This is a very cool video because this addresses a lot of the misconceptions out there. People are saying, hey, Borna, fiberglass rebar is brittle. It doesn't give you the warning. It doesn't do this. It doesn't do that. Well, we have done a lot of testing. This test has been done in University of Concordia. This is a simple beam, 16 feet span from center to center of the support. This is a 300 millimeter or a foot long high concrete, regular concrete, 6 inches, and 2 pieces of number 5 rebar running at the bottom. And we put this at the cyclic loading of 2 hertz, 2 cycles per second. The loading on top is 25,000 pound force or 110 kilonewton, 1.7 times service load. And this video has been recorded after 2 million cycle. We did the same test with steel, and it only lasted less than 20,000 cycle. Oops. So there's a misconception out there, hey, fiberglass doesn't deform, it breaks very fast. Well, that's not true. If someone can't see this deformation, I know a good eye doctor. That's always I tell people is that, hey, you want to see the crack opening or you want to see your structure deforming. So a lot of misconception out there, and our R&D teams are really trying to resolve them one by one. Some of the really cool applications we have done, caissons, tunnels, big diameter rebars. The picture on the left side is really showing you guys some number 10 bar, number 11 bar verticals, number 5 bars, round circular bars, the stirrup. So we have done a lot of heavy civil work, and now we're doing a lot of residential work. So I'm going to show you guys a lot of heavy civil work and a lot of, regular residentials. Some of the big projects, entire bridge reinforced with MSD bar, not a single piece of steel in there, from foundation in the middle, pier caps, columns, everything reinforced, retaining walls, everything reinforced with fiberglass, and once for all, you're removing the whole steel out of the equation. That means there is no corrosion. One cool video just to show you guys how light the material is. This is 25 pieces of 10 millimeter bar, 12 millimeter bar, half an inch, 20 foot length bar, and we literally have to find the skinniest guy at the job site to help us lift this. So the weight, one side is really the labor, the other side is transportation. So by lowering the transportation number of the trucks delivering the bar to the job site, you're definitely eliminating a lot of the carbon dioxide footprints. 300 feet, 250 feet diameter slurry tanks for animal waste. The owners used to change this every eight years. What is the cost of demolishing all that concrete, rebuilding it? How much carbon dioxide are you putting into the environment versus by using something that doesn't rust, you're increasing the service life and you're not having any corrosion problem. Some more of a bridge deck on the left side, and on the right side, simple footings and foundations, really no limitations. And more residential pictures. Picture on the left side, you see a casting place bridge deck. Picture on the right side is a precast bridge deck. And we're using fiberglass rebar to also repair. So it's not always building a new structure, but we are actually using it in a repair applications. That you have a damaged column, you put fiberglass around it, you put some fiberglass shell on the outside, pour your concrete, and you build a brand new concrete with non-corrosive material in there. And that's the example of the repair. You can see the column. A little bit on the residentials. I'm going to finish the presentation soon. Simple footings, walls, 8-story buildings. These are number 11 bar. You lift it on the roof, easy to work with. The labor's performance are really to the roof. The guys are doing things fast. Parking garages, this is 2 level below grade, and the workers have to carry the bar by hand. So imagine you're carrying some number 11 bar by hand 2 level down. It's exhausting at the end of the day. And it's a little video just showing you guys where it has been used in residentials. These are shear wall applications, and I think 80 shear walls in total. Materials delivered to the job site, fast, easy. To the next slide. Really 2 more slides. Last one. Why GFRPs? In terms of being greener and lower carbon footprint, by reducing the delivery 4 times, you're reducing the number of the transportation trucks you're going to do. So you're emitting only 1/4 of the carbon footprints by just transportation. By increasing the service life of a structure, you're definitely reducing the carbon footprint in the environment by less demolition, less concrete handling, and so on. Less maintenance, better insulation. The material doesn't conduct. So if you have a wall full of rebar, that steel rebar is a conductive material. It's bringing all the colds and heat from outside to inside. So saving energy, lowering the energy, much lower energy to produce MSD bar. And the last slide is really showing you how much bar you're actually putting on a truck versus the steel. You're barely gonna fill up the first row. Thank you very much, everybody. I hope you enjoyed the presentation.